The topic is very interesting. I think you chose well. It's about the role of epicardial fat, of intramyocardial fat, in arrhythmogenesis, and that is related to work by Natalia Troyanova, who recently found out that the risk for ventricular arrhythmias is more accurately predicted by intramyocardial fat distribution than by fibrosis. And probably the same goes for atrial arrhythmias. And I'm particularly interested in this subject because we've been doing experiments on this topic. We've been looking at the fat secretome that exerts rather specific effects on myocytes if they are closely in relation to each other. And that's exactly what is the case with these intramyocardial fat in the atria, but also in the ventricles. So Ewan, if you want to start off, the floor is yours.
Thank you. Hello, everybody. So today, as part of the Journal Club presentation, I'll be talking about an article named Assessing Left Atrial Intramyocardial Fat Infiltration from Computerized Tomography Angiography in Patients with Atrial Fibrillation. It was published at the end of last year, I believe, in Europace by Saglietto. So as a quick reminder, I'm sure everybody here knows what atrial fibrillation is. It's the most common type of arrhythmia found in clinical practice. It can be due to ectopic activity or reentries. It's characterized by a rapid and incomplete contraction of the atria, and the rhythm is characterized as rapid and irregular. It's also very complicated and multifactorial disease with, as you can see, a lot of risk factors that can be involved, ranging from cardiovascular diseases or systemic diseases. Here you can also see that obesity is characterized as a risk factor, and we'll focus on that for this presentation because infiltration of fat in the atria, more specifically the left atria, or from the presence of fat, whether epicardial or infiltrated fat, is found in atrial fibrillation patients often. And as Ruben said earlier, there's it's a new field of interest to better understand the disease. At first, it was believed that fat infiltration could have some role with the with the interaction with the inflammation processes in the atria. Now it's some people studied more specifically as the presence of fat in the atria, such as here. So the hypothesis for this paper, if we summarize it, is there a modified and/or increased infiltrated fat adipose tissue volumes in patients with AF, where they chose to study paroxysmal AF and persistent AF patients compared to patients without AF history. For this study, overall, they had a total of 80 patients with 30 patients with paroxysmal AF, 30 patients with persistent AF, and they they age matched 20 control patients, and all those patients had some CT scan conducted on them. The only relevant difference in those patients is the body mass index that was significantly lower for the control patients, and also to note that they chose to not to include patients that that had a significant left atrium remodeling. So if the diameter was above or equal to 42 millimeters, they were excluded from the study. So they used, like I said, multi-detector computer tomography for this study. So quickly, the pros that is they use 2D detectors. It's also a shorter acquisition time, and it improves 3D rendering, which was used a lot for this study with 3D wall thickness maps and 3D infiltrated fat maps. The the main drawback is that it's patients are subjected to a higher radiation dose. They also decided to segment the left atrium into 19 different segments, and from using those CT data, and also all the data was post-processed to obtain those 3D maps, whether wall thickness or infiltrated adipose tissue maps.
Another question, Ewan.
Yes.
I believe there's no contrast needed for this measurement, right? The fat is white on the images.
Yes.
Correct?
Yeah, they did. I put the well, here you don't see it, but they didn't show any proper CT images in the study. They just showed those 3D maps.
Okay.
So yes, I believe it's in white.
No, I just to interrupt, but it's not. It's a contrasting on CT, and fat on CT appears very dark.
Oh, okay.
So you
Yeah,
use the blood pool that is enhanced to segment the blood pool, and
Yeah.
then you segment the wall around the blood pool, and you identify pixels that are very, very low in attenuation.
Okay. Thank you.
So if I continue, so first of all, they assessed the overall volume and wall thickness of the left atria in those patients. So they to be honest, they used a lot of subgroups and groups and different statistical methods that they had a big table that I chose not to present because it was quite complicated to understand, even with the article just under with me. So sometimes they compared all the three groups together, which is represented with the p-value that we see here, and then they also compared the subgroups to each other, but they in some tables they did not show the results of those calculations. So here they say that left atrial volume and left atrial wall thickness was significantly different between all the groups, but they didn't see significant difference between paroxysmal and persistent AF patients. So overall in the study, when they talk about significant difference, it's most of the time between persistent AF patients and the control patients. So it'd be nice to keep that in the back of your mind, as here. Then they studied by measuring reduced radio density, the volume of infiltrated fat in the left atria, and they subdivided the infiltrated fat into dense in fat and fat myocardial admixture. So they had different thresholds to measure those subgroups. But overall, what they saw was a significant difference in fat volumes between AF patients and controls, and most of the time was the difference was between the dense in fat subgroup and the the control group. To continue with the 3D in fat maps, what they saw was that the infiltrated fat was distributed almost everywhere in the left atria, but we'll come back on this later because they did additional study for later, and they also did those just as a visual representation, the 3D wall thickness map. And after this, what they did was they superimposed this 3D wall thickness map and the 3D in fat maps, and they it's quite it's a qualitative representation that the distribution was throughout the thickness of the left atrium wall, and also distributed everywhere in the left atrium. So
that figure was not clear to me. What am I looking at?
it's the small yellow dots that you can see is the left the infat map, the 3D infat map,
Yeah.
and superimposed on the 3D thickness map. So they wanted to see if whether the infiltrated fat was more present in the thicker or thinner areas of the atria.
Yeah.
So they didn't see any significant difference in this distribution. But when they looked at the regional infiltrated fat distribution, except in the right superior pulmonary vein and the left superior the left superior pulmonary vein, the distribution was not significantly different, except in those areas where in those AF patients they had more the distribution was concentrated in this area. So as a quick conclusion, well, to summarize a bit, quite a lot of the data they show was rather qualitative, and if you're interested in the in-depth data, I have it in as a backslide, but it's quite a heavy table, so I can show it to you afterwards. But as a takeaway, what they saw was that in persistent forms of AF, that it was associated with a greater degree of left atrium in fat volume, those patients presented a higher in-fat volume around the superior pulmonary veins, but in one of their in their limits, they stated that even if they assessed those in-fat layer levels in those AF patients, they had yet to show a causal relationship between modified in-fat volumes and the presence or the aggravation of AF in those patients. And so that was it for the presentation. Can answer to your question, and I think Jocelyn
Yeah.
also had interesting points to talk about in the limits of this paper.
Yeah. Well, thank you, Ewan. Well
So-
done. I have the impression that the statistics of the paper are not very strong. Is that correct? Is that your opinion too?
Yeah, it's I don't know if I would say it's not very strong, but if I can show you that's the whole table. So they did a lot, like to try to find some significance. They did a lot of different statistical analysis,
Yeah.
and they had a lot of groups. They had a lot of subgroups, and so, like I said, even with some time to read the paper, it's quite complicated to understand well, which subgroup they're talking about and what they're comparing it to, in which condition and such. So
Yeah.
so yeah, it's they did a lot of they dug a lot to find some significance, I would say.
Yeah, exactly. Yeah, and apart from that, I think the main problem is that there's an association between the fat and atrial fibrillation. No, not a causal relation, of course. You can't exclude that the fat is the result of the presence of atrial fibrillation, for instance. Although I don't believe it, but that's still a possibility.
And what do you
So,
think about their main conclusion?
yeah, can you bring it back on the main conclusion?
Saying that there's really a link between intramyocardial fat and like persistent forms of AF are associated with a greater degree of LA in fat volume.
Yeah. Well,
That seems to like indicate that there's more fat infiltration in these patients. But
Yes.
when you look at the table that they just showed us, doesn't seem to really be the
No.
case.
no. The other table, I think you mean.
No, this table, I mean,
Yeah,
you
yeah.
have, if you look at the absolute volume, okay, but actually that's not really the point, is it? I mean,
No.
these are patients that have higher LA volumes. These are patients that have higher thicker LAs in their cohort, which is a little bit strange, by the way.
Yeah.
And then, in fact, when you normalize to segmented wall volume, which is their third lines, doesn't really show up. I mean, there's no real difference. You get only a statistical difference in terms of dense in fat,
Yes.
and the rest is not significant. I mean, you get between 3 and 4% of fat inside the atriums, whatever the group.
Yeah. And that's not much, is it?
No, it's
Yeah,
not much.
especially knowing that these quantifications, the robustness of these quantifications can be debated, and they do not produce intra and inter-observer reproducibility in these measurements.
No.
Because when you do that, the segmentation of the endocardium can be automated, but the segmentation of the epicardium to
Can't.
get the wall volume, the thickness, is manual. And each time you make a mistake there, you include fat because there's fat everywhere around the atrium. So it's not a surprise that they find fat around the PVs because it's the thinner areas, the closer you get to the ostium, you know.
Yeah.
So yeah, I don't know what to take away of this paper.
And same thing goes for the relative distributions. So the relative distributions are actually given as percentages of the total fat that was segmented for one given individual, which means that, for example, let's say persistent or paroxysmal AF patients have bigger veins,
Yeah.
they'll have bigger fat, they'll have more fat volume. So it doesn't make any sense,
No.
actually.
No, that's a very weak point. Yeah.
And for these patients, it's the same. Basically, what this table tells us is that they have the same fat content in their atrial walls. It's just that persistent AF patients have bigger atrias. So
Yeah.
they have more fat volume because they have more muscle volume, but they have the same normalized fat content.
Yeah.
So I would tend to completely, I mean, at least their data, even if you like, not even looking at the pathophysiological consequences of this, if
Yeah.
you just look at their data, in my opinion, their data does not support their conclusion.
No, you're right. Yeah. Good point. So what does still stand in the conclusions? Can you bring them back again? So the first two are gone. And the third is
Yeah.
open door. Yeah. Not a very good paper then.
No.
Poor papers are good for journal clubs, it teaches you a lot. Yeah. Although I must say, Jason, that the idea of fat, the pathophysiological role of fat is interesting. You did some simulations where you increase the fat in the left atrium, I believe, and then at a percentage of 75%, you could induce reentry.
Yeah, that was, I mean, there's twofold, right? You have the density overall, which can impact the amount of substrate, but you also have, in our case, influence on the electrophysiology as well on top of that, right?
Yeah.
So the adipose tissue was also impacting that. So alone with just the substrate, it would be similar to fibrosis studies in a sense, right? But it's an insulator as well, and may also have impacts on that, which is more interesting. And the fact that if fat even kind of sat up by the pulmonary veins, that's opposite of what we're talking about. This is where all the triggers are. So in terms of its role in maintenance and all these things, I wouldn't really see that being an interesting point either. From an ablation standpoint, it'd be interesting because ablating over fat is probably tough, but from the standpoint of persistent AF, I don't understand how that mechanistically would link to other things.
Well,
based on our previous study.
And how about epicardial adipose tissue?
Yeah, if you move away from just the intramyocardial tissue, what do you think about like the epicardial and paracrine effects?
Yeah, this was what we were talking about with the simulations of Jason. That was epicardial adipose tissue. But the idea is that the epicardial adipose tissue invaginates into the myocardial layer and thereby separates the myocardial cells, like fibrosis does, and thereby produces a arrhythmogenic substrate.
And
it also
Hubert,
changes
maybe,
resting potentials. Sorry, go ahead.
Maybe Hubert and maybe others do. So there are some papers about like the fat quality, so the absorption of the fat and how potentially like inflammatory fat can change the absorption of X-rays. Do you have any opinions about that?
Yes, I think this is an area that is extremely interesting. But again, the problem is that it's highly susceptible to noise, these measurements. And the problem with CT is that image noise is directly related to patients' BMI. And I think it's going to be a struggle using the current generation of CT systems to extract robust markers of that. So it's been attempted a bit in the atrium, but it's a huge effort also in the pericoronary inflammation. There's a startup from the University of Oxford on that, who is developing a software to analyze the density of fat around the proximal parts of the coronary arteries in order to get a predictor of acute MI, in fact. And yeah, maybe the photon counting CT system will be more robust to that, but for now it's a bit complicated. It's a bit complicated. The problem is when you have noise in the image, it's complicated to generate a relevant map.
Yeah.
What you can do is average a lot. So for instance, if I was doing such a study on intramural fat, I would have averaged all intensities in a mid-myocardial layer to be as distant as possible from the epicardial fat and from the blood pool, and averaging it entirely to generate a number of average attenuation. And if it's lower, then probably it's fat, you know. This is more robust, but obviously it doesn't give you a map. It's just giving you a number.
Yeah. And can you discriminate between inflammatory?
Yeah, when there's inflammation,
Yeah.
fat gets denser because there's water in fat. So
Okay.
fat attenuation values are between -300 and -30 Hounsfield's unit,
Yes.
and water is around 0. So when you add 0 to something that's between, it kind of gets denser. And this is what these methods are targeting, a densification of this fat. But there are limitations to that. It's that when you have a lot of noise, you cannot discriminate between these, and you cannot compare patients with different morphotypes because there's too much noise in the larger ones.
Yeah, got it. And coming back to your point of the pulmonary veins, Jason, you say that the triggers are coming from there, but you know, Lisa Gottlieb in Bordeaux has shown that there is a substrate for reentry in the pulmonary veins as well. So if you can influence that by increasing fat, then that could generate a substrate.
Yeah, there's lots of work from
with
even from Melez. Melez
Yes.
also did her PhD on that,
Yes,
or
Yeah.
master's.
yeah,
Yeah,
that's
she was in
correct.
Holland.
Yeah,
Yeah, I mean, if we increase the accuracy of how well we could look at the distributions of fat, I mean, that'd be great. But
Yeah.
but even going back to the premise, does fat infiltration equal increase of LA volume? That would mean it has to happen everywhere, right? I mean, I don't know. It's just the idea of fat where it is really important. I think the location, structures, types, all of that. I think that has not yet been clear to me in any really good study and modeling on top of that. So I think that's really where we're at. It's kind of cool.
yeah.
But
I think the point Jocelyn wanted to make is that if you have larger left atria, that you have more fat by definition because of their method of measuring it. Is that correct, Jocelyn?
Yeah, so basically I was saying that larger left atriums means larger LA muscle volume because you have a bigger structure, and therefore mathematically larger absolute fat volumes. But if you look at the relative fat volumes and you normalize to the myocardial tissue volume, then you see that there's not much of a difference. You stay at around 3 to 4% in all patient groups. And it's also surprising, and Hubert said this as well, that they have actually thicker LA wall thicknesses for persistent AF, which is sort of opposite of what we expect. And we know that you're going to get, like, if you have a wider segmentation on the epicardial side, you're going to include fat inside your model that's not supposed to be there. So these two things taken together, plus the fact that they have patients with higher BMIs in the AF patient groups, I mean, it makes this paper, the conclusions, really not very, very strong.
No.
Plus, if you look at the difference in volume between persistent and paroxysmal, it's approximately the same LA volume.
Yeah.
So it's not, you know, really long-standing persistent. If you come back to the first, I think it was 106 versus 103 mLs. Usually paroxysmal AFib patients have almost normal LA volumes. Yeah, look at that. Even the paroxysmal have a larger volume than persistent.
Yeah. So I think they wanted to exclude like the patients that had too wide an LA volume because they wanted to say that their absolute values were interpretable, which I think they are not.
Okay.
So I think this sort of study would be interesting to redo, but really normalizing based on the fat on the tissue volume and potentially looking at the endo to epi distribution, they sort of showed this figure that they went showed where you had dots inside the myocardium pretty much everywhere, but you should do statistical analysis of this and see how fat content decays.
I'm not sure it's doable in vivo. I guess what we could do is if we have in the cadence or harmonica hearts, if we have patients with history of AFib or aging patients,
Yeah.
we may want to do fat fraction mapping on the 9.4 Tesla MRI to understand exactly what heterogeneity is expected with respect to fat infiltration in the human atrium. I don't think we have the spatial resolution and contrast resolution yet in patients to do that. We can probably have we probably have already technologies to extract some numbers that approach a global fat remodeling or something like that. But a detailed distribution of the transmural analysis of the transmural distribution of fat on this very thin atrial wall, I don't think we are there yet.
No. And I think the interesting parameter is not so much the volume, but the interaction with the myocardium, so the relation to the myocardium. Vladimir has a question or a remark.
Yeah. Yeah, thank you. Yeah, first of all, thanks for presenting this paper. So I have one question, which maybe I missed the information at the very beginning, but the AF patients, did they have some prior ablation or not at all?
No.
So none of the patients in the cohort had previous ablation?
No, this was pre-ablation CT.
Pre-ablation. Okay, good. Then my next remark is, yeah, I don't really understand in the tables, like why there is this total column, like all patients together, because this is clearly mixing the AF patients and control patients. So
Yeah.
what does this really tell? This to me this doesn't really tell anything, because
Yeah, you're right. Yeah.
it's either I want to know about
We
AF
usually do
patients.
that in clinical papers to describe our population, but you're right.
Mhm.
When you're comparing two controls, you shouldn't mix diseased patients and control patients.
Okay, thanks. Yeah, because this was really like strange for me, like for interpretation. And then the third remark was actually on the slide that was there previously, the one with the colorful thing, where also Ruben had a question.
This one?
Yes, yeah, this one. So what does the red color mean? Because it's not on the color bar.
It's the
Yes,
Yeah,
it
it's
is, but
below
you can see
one.
it's below one.
Oh, is that
Wait.
below one?
It's just like
Oh, okay.
it's in front
I
of the
see.
red, so you don't see it.
Oh, okay, I see. Okay, thank you. Yeah, that was a little bit mysterious for me. Great, thanks.
All right, thank you. Any more comments? So I think the summary is that this is not very convincing proof of the role of fat in atrial fibrillation. Although I must say that the idea of the influence of fat is appealing, and it's picking up everywhere. It's spreading that idea that epicardial fat can influence electrophysiology. And in fact, we've done experiments with a secretome from fat, from human from patients. And if you subject myocytes to the secretome, you see that they depolarize, so the resting membrane potential becomes less negative, and thereby the conduction velocity goes down. So I think there is a role of fat in arrhythmogenesis, but probably this study does not help finding support for that. Is that more or less a summary of what we've seen, Ewan?
Yes. The idea that they wanted to study was interesting, but like everybody said, I think the methods they used and the what they focused and such wasn't maybe the best choices. So maybe further the study or redo it, like Jocelyn said, with other parameters or such, and to have a more in-depth and conclusive results.
Are you planning to do that, Jocelyn?
So no, I'm not planning to do that. But I mean, if we had to redesign such a study, I think we would make different
Yeah, but for
choices.
your information, we're working in this domain a lot. We have these algorithms to measure wall thickness in the atrium, to identify intramural fat, and also to identify and quantify epicardial adipose tissue around the atrium. And within the BEAT-AF randomized controlled trial, one of the ancillary studies that we recently discussed is to analyze the effect of global fat content, both epicardial and intramural, so separately, on the results of ablation, the outcomes of ablation, and also in analyzing in the two groups, the group with RF and the group with pulsed field electroporation, to analyze whether the tissue composition on ablation sites was different depending on the recurrence or not, and pulmonary vein reconnection at redo. So this is something we are exploring, and but we will try to do a better work at engineering the image processing methods and less work at engineering our results.
Yes.
Yeah, because it looks like they wrote their conclusion because it was, as you said, Ruben, it's very trendy to talk about intramyocardial fat. So I think they wanted to reach this conclusion, and they designed their methods so that they did.
Yeah. Well, maybe another approach would be to look at patients undergoing bariatric surgery and then quantify epicardial adipose tissue. I think that has been done already in part, but I'm not sure about the imaging.
Or with these new drugs, you know, these
Yeah, the
I read in Le
Wegovy
Monde,
and
the Novo Nordisk
Yeah.
vaccine against obesity. Yeah.
Yes.
One would want to follow up the atria of these patients and the
Yes,
ventricle.
exactly. Yeah. Because it does help against atrial fibrillation.
Yeah.
Yeah.
Yeah, Prash Sanders has shown that a lot, and now they have a drug.
Okay.